So, welcome again. So, today's activity is we are asked to find the asymptotes of the following functions. F of x equals x plus 3 all over x minus 4. G of x equals x squared minus 9 all over x squared plus 2x plus 1. Number 3, you have h of x equals 1 over x squared plus 1. And j of x equals x cubed plus 1. So, again, let's review what are the three asymptotes that we have discussed. First is the vertical asymptote or the VA. Next is the horizontal asymptote or the HA. And the slant asymptote or the SA. Okay, so let's start off with number 1. So for number 1, first we will identify the VA. So to identify a possible candidate for VA, let's look for the zeros in the denominator. So let's equate the denominator, which is x minus 4 to 0. Solving for x, you will get x equals to 4. Now this means that at x equals to 4, the denominator of the original function f of x is equal to 0. Now let's test if one of its one-sided limit approaches to infinity, because that is one of the conditions for the VA. Okay, so let's test. So limit as x approaches 4 from the right of the function x plus 3 all over x minus 4, which we will apply directly. So you have 4 from the right plus 3 all over 4 from the right minus 4. So 4 plus 3 is approximately 7. And then 4 plus is 4.01 approximately. And then minus 4. So that is 0.01, or that is 0 positive. So that number divided by 0 positive is approximately positive infinity. Now since we get an infinity for our answer in the limit, so therefore our VA or x is x equals to 4. Okay. Next is we will identify the horizontal asymptote. So we do this by getting the limit as x approaches infinity of the function. So in either side. So x approaches infinity of x plus 3 all over x minus 4. Okay, so by properties of limits, we can say that this is just equivalent to limit as x approaches infinity of x over x, or that is x over x is limit as x approaches infinity of 1, or that is equal to 1. So since we have arrived at a constant value at infinity, therefore y equals to 1 is a horizontal asymptote or HA. Okay. Next is, how about the slant asymptote? So sa for the slant asymptote, we need to check first the degree of the numerator and denominator of our rational function. So let's have the degree numerator first. So in our degree numerator, we have here x raised to the first. So the degree numerator is 1. Next is degree denominator. So degree denominator is also equal to 1. So let's subtract 1 minus 1 is equivalent to 0, but we for an SA to exist, the difference must be equal to 1. So since it's not equal to 1, therefore the function has no slant asymptote.